want to do over the next 20 minutes or so is just to feedback to you about the TREATWolfram clinical trial and what we're doing as a follow-up from that as well. I'm very grateful for the chance of this. I think so many people have been involved out of the Wolfram community and people who took part in it from here as well, that I really wanted just to feedback to you in person to update you where we're at. So just as a recap for people perhaps who weren't here at the beginning of it, the goal of this trial was to see, can we find a medicine that will slow down the progression of sight loss in Wolfram, vision loss. And if we could find a medicine to do that, could we then get it licensed on the British National Formulary so that we could actually prescribe it as doctors to patients in the clinic? And I'll say now from the outset, I can't yet give you a definite answer whether the medicine that we tested works or not at that point. And I'll try and explain why in the next few slides, so you'll understand where we're at with this as well. So, you obviously know about the condition altogether, that I've been working on it for a number of years to try and understand the history, and that there is no licensed treatment that as doctors we can prescribe in the clinic to slow down the progression of Wolfram. There are very few, or have been very few, clinical trials, and that's because of its rarity, affecting probably 1 in 500,000 or less, because people affected are spread all over the country as part of this and not concentrated in one place to take part. Because although it's a neurodegenerative disorder, it's relatively slowly progressing compared to some other childhood ones, and therefore to show that you're making a difference, you have to follow up for a number of years to do so. And we've got no blood-based test to actually say within 6 months is the treatment working or not, or at least not yet anyway, to do that. And at the time we set the study up, the regulators, the people who decide what medicines we're allowed to prescribe, were very, very strict, and they wanted a gold standard trial, which is what's called a randomized controlled trial, to prove the evidence that something works, with a dummy medicine group, a group who had placebo. And that's not ideal for patients who obviously want to be on a treatment arm for it. Got that. So we went 11 years ago now to the European Medicines Agency, the regulator, and got orphan drug designation for a medicine that's already licensed for use. It's called sodium valproate, or Epilin, and you may have heard of it because it's a drug that's used to treat childhood epilepsy and adult epilepsy for a number of years. And we chose that medicine because we've done laboratory studies showing that it works in cell models, a little bit like the models that Dr. Sovan Sarkar was talking about this morning. And it seemed to help cell survival in cell models. And it worked in a mouse model from colleagues in Estonia in improving the diabetes of the Wolfram mouse. And subsequently it's worked in other cell models from doctors in Belgium for this sort of Wolfram and other sorts of Wolfram as well. So the data we had suggested that because sodium valproate protected Wolfram cells and kept them alive, it would be a reasonable thing to test and see if it worked in the condition itself. So the research question we tried to answer was, does the treatment with sodium valproate slow the rate of progression in Wolfram? So it's not a cure, but can we actually change the natural history and slow down the rate of progression of the condition? So we had to do a design that the regulators approved, so that should it work, they would then be able to license the medicine for use. And the cartoon that I'm showing shows that after a screening period of about 4 weeks, we invite people to take part, and then they're randomized by a computer-generated code to either be allocated to treatment of sodium valproate or placebo as a dummy medicine that looks like the real medicine on there. But the people who are taking part were not supposed to know whether they were on a treatment or not. And the doctors who are doing the trial are not allowed to know whether they're on the treatment or not. So that's called a double-blind, randomized controlled trial. And to get enough patients, we recruited patients from Poland, Spain, France, and the UK. And people were followed up for 36 months, so that's a long time, as you know, 3 years, with a visit every 6 months to check the vision, and a visit every year for blood tests and brain scans to check. And all that data was collected up in the clinical trials unit. And at the end of the trial, the statistician went away into a dark room somewhere and worked out who was treated with what, and then compared the outcomes of the two different groups. And I wasn't allowed to know until about June time, where we were at that point. The trial started in January 2019, when the first participants were recruited at Birmingham Children's Hospital, and it ended in October 2024, when the last patient had their last visit. So it went on a long time. And the reasons for that partly were because of difficulties in getting the trial set up and getting the medicine, but also COVID happened in the middle of it as well. And of course when COVID happened, a lot of visits were paused and visits to hospitals were paused as well. So the end point to see did the medicine work was to see the rate of change in vision over 36 months. And we chose vision because we asked the Spanish Wolfram Association, the Snow Foundation, Wolfram Syndrome UK, and the French Wolfram Association, what did they rank as the most important symptom to try and do something about? And all of them put vision as number one. So that's why we chose that endpoint from it. But we also wanted to see, did the medicine actually slow down the progression of other things? So we were doing head scans to look at the brain volume and different bits of the brain. Diabetes control, did it help sugar control in diabetes? Did it help vision? When I say vision, other things like OCT and colour vision and things. Did it help balance sleep? And then was there any connection with the sort of genetic mutation was at the end? And throughout it, we had to show that the medicine was safe and that we weren't doing any harm to anybody by taking part in it. So there's a safety parameters as well. So to measure vision, we had to use a special chart called an EDTRS chart with numbers across it and a special scale called a log-Mars scale. And you'll be familiar with having a vision check, and you see this often an inverted triangle on the wall, and you have to read out the numbers of the letters, and as you go down, the letters get smaller as you go along. Well, this chart does something very similar in a very standardised way, so that all vision could be collected the same across all 6 centres around Europe. And what we were trying to do was to look at the rate of change of vision loss. And what I'm showing on here, on the vertical axis, is visual acuity, how good the vision is, and 0 at the bottom is 20/20 vision. That's perfect vision. And 2 at the top means you can just about count fingers in front of your face, but that's all. And on the horizontal axis is the age of patients from 10 years, 20 years, 30 years. And each individual coloured line that you might be able to see on there is an individual patient from St. Louis Research Clinic, supported by Dr. Tammy Hershey and others as well, followed up over a number of years. And each of those individual lines goes up from the bottom left to the top right, showing that over time, people with the childhood onset Wolfram, the vision gets worse over time. And if you take the average of those, which is that central line up the middle, you can do an average rate of progression over time. We recruited enough participants to see that if this medicine worked, we could slow that rate of change by half. Now what that would mean in reality is that over 3 years, the people on the treatment hopefully could see a whole line higher on the vision chart than the people on the dummy medicine. So not just a letter, but a whole 5 letters better than the people on the dummy medicine. So that was the size of the difference we were trying to see. And in theory, that might mean that somebody who was diagnosed at the age of 10 with Wolfram, without a treatment, might have severe vision loss by the time they were 18. But if the treatment worked, they wouldn't develop severe vision loss till they're 25 or 26. We should allow them time to get through college and early years in working and retain good vision for much longer, well into their early adulthood as well. So that's the sort of size of difference we're trying to get to. So we recruited, or we approached almost 90 people from across Europe, 89 I think, to assess for eligibility. Because of the time it took, when we got down to it, I think we got to about 65 that were eligible. And the problem was we had to have people whose vision was good enough that we would continue to be able to measure it over the 3 years. And it's to my lasting regret and sadness that there were people who'd like to have taken part, but because of the delays in getting set up, the vision unfortunately had progressed and we weren't able to recruit them at the start of this study. And I'm really sorry about that time. We were able to recruit 63 people whose vision was good enough that we could follow it over the whole 3 years. 42 were randomised to sodium valproate, that's that left-hand side, and 21 were randomised to dummy medicine or placebo group. And then they were all followed up over the time. In the group who received sodium valproate, 7 stopped early, either because of side effects, because they felt they were gaining weight, or losing some hair, or decided that they didn't want to carry on because it was quite hard work taking part in the study. And in the placebo group, 3 people, so the same proportion, stopped for the same reasons as well. And I think that might be because we were asking a lot of participants to take part. So at the end of it, we have to analyse everybody who were allocated the treatment, whether or not they completed the trial or not. That's called an intention to treat. And we had to analyse everybody in the placebo group, whether they finished or not. So I think it was about 35 who completed the study in the treatment group, and it was about 18 who completed the treatment in the placebo group. So those are the sort of numbers. So this is the number bit. When we look at everybody at the beginning of the study, the people in the placebo group were younger, they got a shorter duration of vision loss, they had better diabetes control, and they had larger brainstem volumes than the people treated in the valproate group. Now that's a big problem. In an ideal world, the computer or the statistical group would have made sure that as people were recruited, we check how old they were, how long they've had optic atrophy, and you what's called stratify. You make sure that each group is balanced for all those different things. To do that, we would have needed about 120 people to take part. And it was a real struggle to get 63 because the condition is so rare. So it was a compromise that we had to make in order to complete the trial. And it's a learning point for us going forward in the future. So as it is, we've ended up with a control group that doesn't match the treatment group. So it's important for me to say that now before I go and have a look at, show you the results that we've got from there. So it's a bit like comparing apples and pears, and I'll explain how we're trying to address that. So the primary outcome was what's called vision acuity, and this is the rate of change in vision over the 3 years of the study. And I can explain the graph on the right. In the background, in the coloured lines, are each of those 63 people with their vision measurements measured over the 3 years. And those in the orangey colour are the people who are treated with sodium valproate, and those in the light bluey colour are those who are treated with placebo or dummy medicine. And for those of you who might not be able to see here, both lines go in parallel, and they go very slightly from the bottom left to the top right. Because they grow in parallel, that means that we're not seeing that difference between the treatment group and the placebo group. The annual rate of change in the vision for the valproate group was what's called 0.04, and in the placebo group was 0.04, and in the valproate group was 0.03. To turn that into English, what that means is over 3 years, the people treated with sodium valproate, instead of being able to see a whole line of letters better than the placebo group, they can see one letter better than the placebo group. So if you were treated with valproate for 3 years, you could see one letter better than if you were treated with a placebo group over 3 years. And that's within the range of randomness. So what we call, it's not a clinically significant difference at that level. Now the problem is, which I need to point out as well, that you can see on the left-hand side that at baseline, these two lines don't start from the same point. What I mean is that the placebo group at the beginning had a lot better vision than the valproate group. And what we know is that vision loss can speed up over time. So we're not comparing like with like. So I can't yet conclude that there's no effect of sodium valproate compared to placebo. And that's because of the design flaw in the trial that we've got. And I'll explain how we're trying to address that in a moment as well. The second result that I want to show you is looking at the brainstem volume by MRI scanning. And this again is looking at the rate of change. We know brainstems gradually lose volume over time, very slowly, very slowly. And we were very fortunate in being able to measure that really accurately across all 6 centres, so that was good. And on the right-hand graph, similarly, you can see all of these lines, which are much closer together this time, because we can measure these quite accurately. And again, the valproate line is in orange, and the placebo line is in blue. They didn't exactly start at the same point on that side, but there was a change. The rate of change in pons volume in the placebo group was what's called 0.0006. In the valproate group, it's 0.002. That means that in the valproate treated group, the volume loss was 14 millionths of the total brainstem more than the placebo range. So when you look at brainstem volume, you compare it to the total volume, the intracranial volume altogether. The rate of change in the placebo group was 6 millionths of that volume over the 3 years, and in the valproate group it was 20 millionths over 3 years. So the difference is 14 millionths. We're talking tiny amounts, but there did appear to be a slight difference in that. And it's known from the literature that sodium valproate over time can cause a little bit of brain shrinkage on that area, but thankfully it's a very small amount. And we don't think it's clinically significant for that. We then looked at diabetes control. There's the third one we looked at. And what we measured was how much insulin people were needing over time. As I've said, the placebo group was healthier than the valproate group. So the placebo group needed less insulin throughout the trial than the valproate treated group. And their A1C, or insulin-adjusted A1C, was a bit better in the placebo group than the valproate group. And again, this is because of the differences between at baseline between the two groups. Looking at safety, when we look at adverse events, interestingly, they were equal in both. So headache was the commonest side effect, but it was equally common in the people treated with sodium valproate as the people treated with placebo. And I blame that to the hospital air conditioning, I think, or going into hospitals and having to have long appointments, which is hard work for anybody to take part as well. But there were some, and there is COVID-related side effects. There are some that are known to be related to valproate, such as fatigue. So that was higher in the valproate treated group than the others. Interestingly, there is more low blood sugars in the valproate treated group than the placebo group. And we know from colleagues in Europe that there may well be an effect of sodium valproate in needing less insulin. And we need to look at this data a bit closer, because there's some evidence that valproate can help diabetes in this. We need to understand. But thankfully, there was no other excess of side effects in the valproate group, nothing that wasn't expected or unknown, and nothing that caused serious illness, and nobody died, thank goodness, but nobody had any other serious illness during the course of this trial. So, to go back to that research question that I started with, does sodium valproate treatment slow the rate of progression in Wolfram syndrome? I'm standing here in front of you and says I still can't answer that question for definite, at the moment, because the placebo group is younger, healthier, and had a shorter duration of vision loss. And I think it was particularly hard to recruit participants from the 4 countries, and it would have been harder to stratify patients by those variables at the beginning. We'd have needed twice as many patients. It was a long trial because it happened COVID happened in the middle of it, and that slowed things down quite considerably. And it was quite onerous for the people who were taking part. I think it was hard work for the people who were taking part. And there were a lot of assessments. Some of those assessments weren't always done correctly. We've had to exclude some of those from here as well. The important things I want to bring out, there. So first of all, it's the first international trial in Wolfram in the world, and we've learned an awful lot of how to set up a trial across different countries. And to get a medicine license, you can't just do it in Birmingham. You have to do it in different countries to show it works in different areas as well. So at least now we've got a network of sites that all know how to work together and can deliver a protocol to the same standard. So we know how to set up a study, and that'll save a lot of time for the next trial going forward. Secondly, nobody before has set up a network delivering MRI scans or brain images, because it's normally really hard to compare brain images from France with those from Poland, with those from Spain, with those from the UK. Thanks to Professor Tammy Hershey sharing her protocol and the hard work of our radiophysicists, we've now got a system whereby we can share scans all calibrated the same way and directly compare them. And you might have seen from the quality of the data, the lines are very close together. So it's really good quality data. And we can pool that in future for future trials. Thirdly, we measured a lot of things in this trial, and it was hard work for the participants. I know some of you in the room took part as well. From those, we can now distill down a set of core variables so that for the next trial, we don't have to do that all again. We know which ones can predict progression and which ones we can drop. So the next trial is going to be much more simple and measuring far fewer things, because we know what's important to measure and what's not helpful. And then fourthly, at least with the placebo group, and maybe adding the valproate group, we've got really high quality natural history data on the condition from 4 different countries that will take the place of the placebo group for a future trial. So if we could do another trial next year of another medicine, we could say, hopefully we don't need to bother with the placebo group because we know what's going to happen because we've got a placebo group from the TREATWolfram trial. And we don't have to ask patients to say, I'm really sorry, but you might end up being on the true placebo arm. So hopefully that will remove that need in the future. And then finally, what we're doing, again, working with Professor Tammy Hershey and others, is looking at the blood samples that were kindly donated to see can we find a biomarker that we can measure in the blood after 6 months that will tell us is the new medicine working, in which case we'll carry on for the vision, or no sign of it working, we'll stop the trial and try something different. So hopefully no more studies that take 3 years to deliver at the end of it. What's really important from the TREATWolfram is that we get all the information out that we possibly can because of all the effort that people went to take part in it. So first of all, we've excluded vision measurements from a centre abroad that weren't done correctly and reanalyzing it, and it's giving us a much better data set. And secondly, we're working with Washington University because, as Stephanie knows in there, they've done a natural history cohort over many years there of people following up to measure their vision. And Professor Tammy Hershey is very kindly collaborating with us and sharing their data. So what we do is we take that data and we add it to our control group to make a better match with the treatment group. And then we reanalyze. I'm really hoping we can do that between now and November. And then I could come back to you with a more definite answer. Instead of comparing apples with pears, we're comparing apples with apples. And that's something that we can only do thanks to the Washington University St. Louis collaboration that's hopefully going to give us a final answer on this as well. So that's and then most recently now, we're working again in collaboration with our North American colleagues to apply to join the European Rare Endocrine Registries in a prospective cohort, so that all of the people who took part, the clinicians who took part across France, Spain, Poland and the UK, with permission of their patients, and their patients themselves can self-register into a European-wide registry of the condition, putting down their information every 3 months or so about the medicines they're on, their vision, etc. as well. So that going forward, we've got a prospective cohort that can be used as a placebo group for future clinical trials as the TREATWolfram one gets older. And that we don't have to go back to collect that natural history again. It's done automatically as part of normal care. And my European colleagues are really keen to be able to do that in a prospective way going forward. And if we can get that set up with support from grant funding, I'll want to come back and talk to you about that next year, and hopefully people will be interested in taking part as well. So I'm sorry it's not all the answers that I'd like to be able to give you, but I do want to explain that we're working really hard to actually make sure we get some definite answers from this and plans going forward for future medicines as we do. And it's really important to thank all of you that helped. The UK Medical Research Council gave the bulk of the funding, but Wolfram syndrome in the UK, massively important for helping patient travel to get to the centres here. And the Snow Foundation, with the eye in French, actually funded the collection of the biosamples and helping with the imaging analysis, without which we wouldn't have been able to deliver as well. Massive amount of people to take part and deliver this trial would be absolutely fantastic. But really, most importantly, our colleagues from the Spanish Wolfram Association on the right, the North American Wolfram Association, the French Wolfram Association, and of course you guys in WSUK. And I've got a photograph here, I think, from a previous conference a couple of years ago in Whitterbury Hall with taking part. So we're really grateful. Thank you very much.
Thank you, Tim. Do we have any questions for Tim? We have a very short amount of time because I need to do a connection to Zoom for our last presentation.
In fact, you can do the connection while I answer some questions, actually.
John, can we...
So yeah, that's a lot of information in a short time, and I'll put updates on the website. But if there's any immediate questions or immediate thoughts, please do feel free to ask the thing. Oh yes, over there, yes.
The comparison with people who didn't take either the placebo or the drug?
That would be an ideal world, yes, except we had to do some really standardised measurements as part of the trial that were not done on the National Health Service. And so therefore, the people who weren't taking part in the trial, yes, they do get vision assessments, but they often get them done in a non-standardised way, or something called the Snellen chart, or the Bailey Love charts, or others. Whereas we wanted everybody to be done by what's called an EDPRS chart and logmark. So therefore, it's quite hard to make a direct comparison. If we could set up a Europe-wide prospective registry, the data entered will be standardised, and then we'll be able to do what you suggest in the future. Yeah, absolutely.
Thank you. I should have said as well, thank you for your presentation and all the work that you're doing. It's really interesting and amazing.
Thank you. Yes.
Helen, he was one of the ones who took part in the TREATWolfram. But have you got a list now of who was on the placebo or who was actually getting the sodium dopamine?
So yes,
interesting to know.
yes, absolutely. So the data monitoring committee and the trial steering committee insisted that people who took part should be informed about whether they were on treatment or placebo. So the clinical trials unit, now they're putting together the case report, are compiling this to go back to the clinical doctors. So in your case, it'll be Dr. Aaron Sturrock who will get the list, and then he will be writing to you to give you the treatment allocation that you were on. Yeah, so we'll try and get to that before Christmas the next year. And just to say thank you so much for you and other people here who took part as well, because I know several people did. Very grateful for all the activities.